Hello, you are welcome to this channel, Research Plus. In this channel, I provide you with AI approaches to research analysis, interpretation, and reporting. If this is your first time of coming to this channel, please subscribe to this channel, and anytime I come up with new quality content video like this, you'll be the first person to be notified. Thank you. Let's take our today's class, and God bless you. You are welcome to class today, and in today's class is coming because of the request that some of my students are giving, that they want to know how would they know that their data is not normally distributed. So this is the reason why I am putting up this tutorial class at this moment. How to know that your data is not normally distributed. But before we go into the lesson proper, I will want to state clearly the basic theory behind this particular aspect of analysis, behind normality of our data. There is an assumption that is made for it to be fulfilled in order for us to run any parametric test or non-parametric test. So we are going to look into this assumption one after another before we proceed. So like I said, that there is a basic theory behind normality test of our data. So I said that there is an assumption to be fulfilled before any parametric test or non-parametric will be done. So one of the assumptions is that your dependent variable should be continuous or measured at interval or ratio level. Your independent variable should consist of two or more independent category groups. 3. Your data should have independent observations. That is, there must be different participants in each group. 4. There should be non-significant outliers so as not to reduce the validity of the result. 5. The dependent variable should be approximately normally distributed. Your data must have homogeneity or variance and other assumptions, that is etc. So you will observe that I have colored number 5 with a red color to make an emphasis that this is where our test of normality is coming up. So for us to run any analysis in SPSS, we must observe that this condition is met. Otherwise, we might be running in error. So in this tutorial, follow me gradually, and you are going to get exactly to know that your data is not normally distributed or it is normally distributed. So for us to obtain and to know whether our data is normally distributed or not normally distributed, there are two methods to use. We have the numerical method, and in this numerical method we have what we call Kolmogorov spin-off test, and we have what we call Shapiro-Wilk. Then another numerical method is what we call skewness and kurtosis. Then the other graphical method is what we call the histogram and the QQ plot. So by the time we collectively check these two methods of checking the normality of our data, we will come up with a result that will show to us that our data is normally distributed or not normally distributed. So just sit down and keep watching this tutorial class. if this is your first time of coming to this channel, as a way of encouraging me to continue this high quality content tutorial, so that we can impart our modern researchers with modern approach to research, you should like this video, share it with friends, and subscribe to the channel, so that will encourage me. So sit down, let's continue our tutorial class as usual. So to check for the normality of our data, I am going to use, for the sake of this tutorial, I'm using these documents that has already been entered into SPSS, and this document has it has 300 respondents, and we are going to use it. The whole of the data is having 5 variables: psycho, counseling, availability, 1, 2, 3, 4, 5. It has one dependent variable, which is well-being, and other 4 independent variables. So we are going to check. They have already been coded, and they are continuous variable, which is one of the conditions for a regression to be conducted. So let me go to analyze. That is our starting point. You go to analyze, you go to descriptive statistic, you go to exploit. In this exploit, I am going to switch it to displace variable name. Here, I'm going to move all my continuous variable to the dependent list, because I want to check the normality of this data. I move them here, and I will click on statistic. So it is already set at 95 level of confidence. I can check for outliers. I will check on it. I will now click OK. I will now come to plug. I will click. I don't want stem and leaf. I want to look for histogram, and I say none for box plug, and normality plug with test. So from here I will click OK, and I will now click OK. It is now going to work out and display to us the parameters for us to decide. Very good. It came up with case processing summary, and in the case processing summary we have 300 population, and everything is intact. Where I'm going to concentrate is I'm going to concentrate on this descriptive statistic, because it comes along with my squealiness and kurtosis. And there is, for this table to be normal, the value of my squealiness and kurtosis has to be equal to 0. So if it is not equal to 0, then it simply means that my data is skewed. So from the first one, psychological counseling, you will discover that the value for squealiness is minus 1.441, and for kurtosis is 2.713, which is greater than 0. And for that, it simply means that my data is not normally distributed at that level. So let's check for availability and access to psychological counseling and services. You will now see the value of squealiness as minus 1.463, and for kurtosis is 1.448. It has also indicated to us that this data is not normally distributed. So I am going to move down to very important thing once again. And just like I told you initially, that when we are using numerical method, we are going to look for Kolmogorov spin-off and Shapiro-Wilk. So for this data to be normally distributed, the hypothesis of this one states that the p-value, our p-value calculated, should be significant. That is, it should be less than 0.05. And by what you are seeing here, the value of our significance, which is our p-value, is 0.0. Look at for Kolmogorov-Smirnov is 0.0. Look at for Shapiro-Wake is 0.0. So by these indices, we check numerically and we'll find out that our data is not normally distributed. Let's look at the histogram. From this histogram, we can also double click on it. As we double click on this histogram, a chart editor will appear. I will now ask you to show me a distribution curve. It will lay a distribution curve on this chart. Okay, because normal chart was set as default. Now let's look at this normal bell curve for this histogram that is displaying as one of the graphical method to check for the normality of my data. You will now observe keenly that from this point you will see that this leg is longer than this one. So by a simple understanding, it simply means that our data is skewed to this side. You will now see that it is skewed and this leg is longer. So this longer leg talks about the kurtosis. It talks about the tail, which is the kurtosis, and when we look at the Q-ness, talk about where the data is concentrated. Is it concentrated to the left or to the right hand side? So by what you are viewing, you can judge from your side where exactly is this data skewed to. So if it is skewed, we call it, if it is to the right, we call it a negative squid. If it is to the left, we call it a positive squid. So you should tell me in comment section which of these squidness does this our chart is having. So I can close this one, and it has proved to us that our data is not normally distributed. Okay, now let's look at QQ-plot as one of the graphical method of checking for normality of our data. Look at it, that the observed value is moving zigzag in a zigzag form. If it were a normal distribution, this our observation will spread along the fitting line. As long as it is not along the fitting line, it is moving zigzagly. It simply means that our data is not normally distributed. So from this point, I hope you are getting value on this YouTube channel. And if you are getting value, as a way of encouraging me to continue, I will want you to subscribe to this channel. I want you to share it with other loved ones so that we can build a community of researchers that will impart our work and bring change to our society. Watch for the next video on how we will, because there is a decision rule that says that if our data is not normally distributed, we should go ahead not to run linear regression, but we are going to run ordinary regression. So you can check off for my video on how I have show you how to run an ordinary regression and how you will interpret the result. Happy research, happy dissertation, and God bless you as you impart our work for a positive change. Happy to meet you next time. Bye-bye, and God bless you.